Welcome to the video lecture for CSE 1040 for April 17th, 2014. So as promised, we're finally going to reveal an easier way to work with strings in C++. And technically this is object-oriented because we're dealing with a string class, although we don't have to be doing anything else object-oriented in our code to use this. So we're going to look at how to declare a string in C++, and then all the various kinds of operations and operators we can use to work with this new way of dealing with strings. And I think you'll find that you are going to be incredibly impressed and incredibly happy that you now have this tool in your tool belt. Okay, so first of all, when we just think of a string in general, it's some sequence of characters. It could have embedded white space, it could have punctuation marks, excuse me, etc. And of course some examples here like the word hello, high school, H2O, etc. What we'd like to be able to do with strings is do comparisons like we do on numbers, and hopefully use the same kinds of symbols and compare them alphabetically, like is one greater than or less than, meaning it's starts with letters at the beginning of the alphabet or later in the alphabet. We'd like to be able to sort of smush two strings together. We call that concatenation, using like a plus symbol, for example, so it's like adding, and do other kinds of things, delete, insert, find substrings, all of which we can do with the C string functions in the string library, but we have to deal with those pesky pointers and character arrays, and we have to worry about nulls and overriding and overrunning the end of the string, writing over the null, etc., and work with scanf and printf and all the syntax that goes along with dealing with strings. And so we're going to eliminate a lot of that with this string class. And here's a reminder of some of that ugliness that we don't like with the C strings. We have to use an array, a character array, and we can declare it such as this one for hi here, or we can use a pointer. We can put individual characters in there, and then we have to be sure we write the null in, etc. Or we can let the system do it for us with things like this last bullet item here. Or we can also create just arrays of characters without the null, but then it's not a string. We can't treat it as a string for purposes of doing things like printf and stuff. So we always have to be careful that if the null is not there, it's really not a string, it's just an array of characters. And so sometimes that sort of duality and those separate sets of rules, the it depends situation can be kind of annoying and even kind of confusing. So that's what we're trying to do away with here. So in C++ then we have a string class. We have to include the string library, so pound includes string. That's if you've included the standard namespace or include string.h. Makes it a lot easier to work with strings and much more convenient, as you'll see in the upcoming examples. So to declare a string using this class, then, just like anything else, we just use string as the name, just like int or whatever. So we can say string x, and then we can put the string that whatever we want to initialize that value x to. We can put it in parentheses, because what we're actually doing there is sort of like invoking the constructor, if you will. Or we can just do it with an equal sign when we declare it, much like we did with the character arrays. Or we can create the string variable and then later, in a separate line of code, notice the semicolon here, assign a variable to it. And we can reassign something different to it later, etc. We don't have to worry about things like how big is the buffer, how many values, how many spaces did we allocate in the array. All those things are taken care of by this class. So if we reassign something else to it later, it'll reallocate space that's needed to hold it as necessary. So all the stuff that these classes do is being done using C, and they're things you certainly could have done and may have done when you were dealing with C strings, but now it's kind of all done behind the scenes for us in sort of an invisible fashion, if you will. So one of the common operations that we do with strings is concatenate two strings together. This could be done and then stored back into memory, or in many cases we do this when we want to print something out. So let's consider the example here, just this code snippet. It's not a complete program, where we've got the first string x is declared to have the word hi, and the second string y is declared to have the word school. And then there's a string z declared that has nothing in it currently. But then the first thing that happens down here is it says z equal x plus y. So this is a concatenation. It's addition for strings, if you will. So it's going to stick hi and school together. Now, since there's no spaces in here, when we print this out, it's going to all be run together. We need to have a space either at the end of hi or before school or as part of our concatenation in order to accomplish that. So then here we're writing it out using cout. This quote z equals is just going to put that out as part of the prompt, and then whatever the value of z is, which was high school. So we see over here on the right, just to the right of that, z equal high school is what's going to be printed out on the screen. We could also do something like this, z equals z plus, and then quotes space was fun. And so now we're going to add to what was in z and add on this extra part of the sentence. So now we have more like a sentence, high school was fun. And we do a cout for that right there. So we can do various kinds of concatenations. If we wanted to put a space in here and we didn't want to change the actual variables in x and y, I could have done x plus and then double quote space double quote plus and then y. So I could have included a space that way as well. So there are several different choices that we have in order to accomplish those kinds of things. So one of the nice things about these classes as well is we can mix up the different types. So we can use the concatenation, and here's an example of s equal u plus v plus w, where all of these are some kind of string, and s is a string as well. U, for example, the first one could be a string object. It could be a C-style string, so a character array or a character pointer. It could be a single character with just single quotes around it. It could be a double-quoted string with just constant string with double quotes around it, like some specific words. Could be a single quoted character. Up here we're talking about a character variable, a single quoted character, and V and W could be those things as well. The only requirement is at least one of those three in this particular example, or at least one of the arguments on the right-hand side has to be a string object. So as long as one of them is a string object, all the other things can effectively be typecast to string objects so that I can do the concatenation. And you'll learn in your future classes how we accomplish that, how we could build a class of our own that would do the same thing. In other words, handle the typecast type operations. We have to actually write functions for that. It's just that this class, that's already been done for you as part of the standard library. So as long as one of the things on the right-hand side is a string object, all the other things can be upcast, if you will, to string objects, and then we can do the concatenation. So here's some examples using that mixed style concatenation. So here we have a string object x that has high, and then y is an array of characters that has school in it, and z is also an array of characters that has the individual characters w, a, and s and a null, and then p is a character pointer with good in it, and then we concatenate all those things together, including some spaces. So here we see adding a space between what's in y and what's in z, which is school and was, which is single character, space, single character. Adding in some constant text here with space vary, another space using double quotes this time, and then whatever was in P, and then actually an exclamation point on the end. So all kinds of mixed stuff here. We've got single quoted characters, double quoted constant strings, single quoted characters as well as spaces, etc. So then I could print that out saying s equal and then whatever the value of s is. And then I could even say s equal and then plus s, so actually make a new string that's a concatenation of those two. So instead of two different parts, just one part. And so notice the different number of angle brackets here for the cout. Here there's 3, there's 2, because this is all one string concatenated together. The output in the end is the exact same, but accomplishing it in different ways. So I can use all different kinds of mixed style context. Okay, we can also use the plus equal to do concatenation, just like we could use the plus equal with integers and floats and all those kinds of things. So x plus equal y when one or the other is a string is the same as saying x equal x plus y, where y can be a string object or a C-style string or a character variable, etc. X in this case would need to be a string object for sure, but y could be any of the possibilities. We can also do comparisons on string objects, and we use the same basic comparison operators that we use for values, numbers, integers, etc. So we can use equal equal, that's actually a double equal sign, looks kind of run together here. Not equal, less than or equal to, greater than or greater equal to, etc. The comparison, however, is alphabetical. So, A is less than B is less than C, etc. So it starts comparing letter by letter until it can determine that one string is either less than, greater than, or in some cases equal to another string. And then the outcome for each comparison is just a Boolean, true or false. At least one of the two items in the comparison, either on the left or on the right, has to be a string object. The other one, again, can be anything that results in a string. So it could be a C-string style variable, it can be a string object, or a double-quoted string. Now here we couldn't use single characters because I'm comparing a string to something. So they both need to be some kind of string, but they could be a C-style string or a constant string in double quotes, as well as a string object. And let's take a look at an example of that. So here again is our string x, which is hi, another string but in the C style, which has school, and then another string in the C style with pointers, which has the word good. And then this says if x is less than y, so is hi less than school, which it would be because the h is less than earlier in the alphabet than s. So, or than s. Oops. So I got way ahead. There we go. Then it says print out x is less than y just as a string, which is what we get over here. If x is less than tree and x is high, so h is certainly less than t, so we don't have to go any farther to determine that, then we'll print out that value. If low is not equal to x, and x is high, and low is certainly not the same as high, so it prints out that value. And if p is greater than x, then in this case g would be greater than h, so that would be true, then it prints out here. And then there's an else, which obviously in this case doesn't get printed. So there we're doing alphabetical type comparisons. Another operator that we have is the index operator, the square brackets. What this does is let you treat the string object like it was a character array, basically. So if you want to get the character at a particular location, you can say x sub k. So here I've created, for example, string x high again. Then said c equal x sub 0, which would be the h, or x sub 1, which would be the I, or x sub 2. So it treats it like it's an array. So we treat it just like arrays, and we can get individual characters out of there. We can also get the length of a string by either doing calling a member function on that object. So if I created a string x again, just like we've been using, I can just say x.length or x.size, and both of those will give me the same information. Even though we're dealing with character arrays, length and size were different. Here, because they auto-size to just whatever's contained in them usually, this would typically give me the same value. I can also check to see if the string's empty by using the empty function, and it'll return a Boolean, true or false, depending on, or be a value, a Boolean value, true or false, depending on whether it's empty or not. In other words, it has no characters in it. So much easier than the ways we've had to do this in the past. I can also get substrings. In other words, I want to look in a string, like in this case, in the example given here, the word product has ROD or rod inside it. So if I wanted to get that, now this is getting a substring, so this is all based on position, not on what the value is. We'll learn how to do that in a minute. So if x is a string object, I can get a substring that starts at a certain position. We'll call that POS, and has a length of len characters. Then I can say x.subster POS, len. That'll return a new string object, which I'm storing over here in string y, that's just those characters. So starting at whatever the position is. So in this case, if I was doing rod, that would be starting at position 2, and then for 3 characters. You can also leave off the length, and if you don't specify the length, then the default is whatever the length of the string is. So it'd start at the current position and then go to the end of the string. You can also default pause as well as length, and then the default position for pause is 0, and of course length would then be x.length, so do the whole thing. So leaving off both of them, defaulting both of them, you'd get the whole string. So that'd be just like doing a string copy, if you will. You can also insert a string into another string. So we say x.insert. POS is the position at which we want to do the insert. So starting from that position on, it's going to insert. Now, insert means it's going to move all the other characters over. It's not going to overwrite. So whatever y is, if it's a string object, or it could be a character array or a constant string, it'll get inserted into there and moving everything else over. So that's a useful function sometimes. We can also do a replace. This is going to do an overwrite. So it looks almost the same. It says, give me a position, and then for length, so however many characters, then it's going to replace that with y, assuming y is long enough at least. So this would actually overwrite. So it's not going to move anything over. It's going to overwrite up to length of len, whatever that value is. So it's going to go from position to position plus len, and it's going to overwrite with the characters in y. And again, y could be a string object, a C-style string, etc., etc. That's going to be a repeating concept throughout the rest of these functions. We can also delete or just erase something. So replace is going to put something new there. If I just want to erase part of a string, then I can do that, replacing it with nothing. So it's actually going to close up, if you will. So I can use the erase function, and it'll erase from the starting position of POS for this many characters, length. And if I want to do it from the current position, whatever position I specify, to the end of the string, then I can just leave off the length, and it will default to x.length. And of course, if I leave off POS and length, it's going to start from 0 to the end, and so effectively erase the whole thing, which is also the same as doing an x.clear. So I can delete what's currently in the string. I can look for patterns or things inside the string. So if x is a string object and I want to search for a string y inside there, I can do that by saying x.find y, and that's going to return an integer that says where does this substring y that I'm looking for, where does it start? So it's going to give me the starting index of the first occurrence, starting from the left, if you will, of the substring y in the larger string x, if any exist. Otherwise, the method returns the length of x. So if I get something back that's the length of x, meaning I got all the way to the end and I didn't find y, then I'll get back the length of x. So I can test that to see. If I want to start searching from a new position, so I want to search, for example, I found one occurrence and I want to search and see if there's another occurrence or find the next occurrence, then I can call find with two parameters. The first one being y, in other words, here's what I'm searching for again, but start at this position. So typically this would be a new position, like wherever you found the first one plus the length of that substring, you'd move it ahead to there and then search again. So this is kind of like the find and find next things you can do in Word, for example. And we'll see a find and replace in a minute. So here's some other examples of, I can also search from the right instead of the left. So our find works the same as find, but instead of searching from the left first, it searches from the right first, and then you can find the next rightmost, etc. So it works exactly like the one on the previous page, but starting from the right end of the string instead of the left end of the string, because sometimes that's more useful. So let's take a look at an example. Here's a string that represents like part of a, maybe from a web page. I'm going to send a message to somebody, or I'm getting a message from somebody. So there's my string that has from, and then, or maybe it's part of a memo, for example, and then it has an email address. So this first thing says x.find, so x is the string, find the colon, and then we're going to save that position. So the colon's right there after the word from, so I'm saving that position. And then what I'm doing, string prefix, so I'm creating a new string called prefix, and I'm doing substring from 0 to colon pause. So I'm going to start from the beginning of the string for this many characters up to the colon. So that's going to basically strip out the word from. So I now know the prefix is from, and then I'm going to get the suffix, which is going to be from this position plus 1, so where the colon is plus 1, so that'd be the A, and get everything from there to the end. Notice we didn't put the length, so it goes by default to the end of the string. So that would get the email address. So now what I've done is this suffix string now has the email address. So basically what I was doing was trying to strip off the other part. I probably could have left off this prefix since that's what I was trying to do once I found the colon part, but maybe I wanted that for some other reason. So now I can say, I could make a sentence, for example, the message is from, and then put in the suffix and would say who the message is from. So we can use this to parse strings and find information inside them. Here's another example. This one also includes something called Fstream, and Fstream is the header file we use to be able to read and write from files other than standard in and standard out, just like we did with fread and fwrite and stuff in C. So we'll get kind of an example of how that works. So the first thing is an if stream, so that all the streams are F streams, file streams, Fstream is an input file stream, so we're creating an input file stream. This is like doing the creating the file handle and then doing an fopen that we did with the C library stuff. So I'm creating an input file stream called in, and this is the name of the file that it's opening. So it's opening this file called inputfilename.txt for reading, and then I'm going to refer to it in my code as in. That's essentially my file handle, although it's an object now. And then I'm creating a string object called body, and also an old style character array called line with 1,000 elements in it. And then there's a loop here, so a while loop that goes from here to down to this closing curly bracket. There's the opening one right there. And this says read a line, so get line into line 1,000 characters, so in.getLine. So this is kind of like gets that we used to use in the C library. So it reads a line independent of any new lines, etc. It reads 1,000 characters worth, if there is 1,000 characters worth. And on the file in, oops, sorry about that. And then we're going to put that into a new string called line string. So we're going to read it in using sort of C-style I/O because we don't want to have to worry about new lines and stuff. Then we're going to put it into a string object so we can mess with it. And then first thing we're going to do is we're going to compare what's in there to see if it's all colons. If it's all colons, pound signs, that may mean something. That may be some kind of a marker that we're looking for. So if it's not equal to that, then we're going to add it to body, which is our string that's basically going to have all the text from the file in it. So we're going to append it with a new line. So we append those 1,000 characters or something like that. That's whatever's on the first line or the next line, and append it to the body. Once we get to a pound kind of thing, it's got all those pound signs. That's a marker that says that's basically the end of the useful text or the text that I'm interested in. So I'm going to keep going through this loop, reading a line at a time from the file and adding it to body until I get to a line that looks like this. Okay. And if I do get to a line that looks like that, then I'll break. Here's the else break. And so I'll be done. And then body will have in it all the text that I read that was up to this line of a bunch of pound signs. And of course, this is just part of the code. This isn't the end. In fact, we don't even see main here. So it's just a snippet of code that shows how we could use these to deal with file layout, for example. You can also use various kinds of these functions to do things like trim leading and trailing spaces. So for example, maybe we have a string that we know may have some spaces at the front. Maybe it's from like a tab, if it was something in a file that was indented, or maybe there's some extra spaces at the end of the line. So this is a function called trim, very useful function. This one's being written here, so it's not a library function, although we could certainly make our own library of these. And it says, give me a string, and in this case it's a string reference. Remember we talked about references last time. So it's kind of like a safe, convenient pointer. So I'm getting in a string from whoever calls this function, and I'm going to refer to as x inside here, and then I need an integer counter. And so this loop here, this first loop, it says, while k is less than x.size, so I'm going to go, this loop is going to continue while I haven't reached the end of the string, and the value that I'm currently looking at, k, which starts at 0, is equal to a space or a tab or a new line. Okay, so space, tab, or new line. So while the size is less than the end of the string and it's a space, tab, or new line, I'm just going to increment k. And then when I'm done, so that loop's just that one line there. When I'm done, I'm going to erase everything from 0 up to k. So that's the leading spaces. So I'm basically starting from the beginning of the string, and if it's a space, a tab, or a new line, I'm going to keep going until I've counted however many of those there are. Then I'm going to erase them all. And then we're going to go into the next part of the function. And so I'm going to set s equal to x.size. So I want to know basically where the end of the string is, how big is the string. And then we're going to go to the right end and move backwards, doing exactly the same thing we did up here. So while s is greater than 0, in other words, I haven't got to the beginning of the string, and x of s minus 1 is equal to a space or a tab or a new line, I'm going to keep decrementing s, and then I'm going to erase from s to the end of the string. Notice we didn't put the second parameter here for s, so it defaults to the end of the string. So I'm going to back up from the back until I get to something that's not a space, tab, or new line, and then erase all those. So between these two parts, these two loops and these two erases, I've removed any leading white space and any trailing white space. So that gives you an idea of how that would work. Okay, and this table just kind of gives you a correspondence of things that we used to do in the C library and the way we would do the same kinds of things using the C++ string class. So string copy, we just use the equal, which is what you guys wanted to do at the very beginning with C-style strings, but you couldn't with C-style strings. String cat is like plus equal or plus. String compare, instead of using string compare and having to get all those funky values, we can use the normal comparison operators like we use with ints and floats and stuff. For all the things to do substring operations, we have .find and .rfind, and for string length, we have .size and .length. So, and there's other functions in the C++ string library class also, but these are some of the most common ones that we would use. So now you have the ability to use those. Certainly in your next homework assignment, you're welcome to use C++ strings since we're doing object-oriented C++ code. And I think you'll find those are a lot easier to deal with than the C-style strings. So I hope this was worth the wait, the semester and 2/3 that you had to wait to find out how to do easier versions of strings than what you've been doing in C. And I hope you find this video useful. And we'll continue and I'll answer any questions next Tuesday when we have class again. Hope you have a good weekend. Hope you've started on your homework. And hopefully this will help you with your homework. And I will see you on Tuesday.